Now, let's see what is the third factor. The third factor is related to the time constraint of the queries. Okay, now let us see what is it. Analyzing the time constraint of the queries and the transaction involves priorities for candidates, attributes to create access path. What does this mean? It means that access path is nothing but an index. Index helps you to make the search process, insertion and deletion process work faster, and hence performance is improved. So analyzing the time constraint is like placing a further priority on the attribute which becomes candidate or which becomes the selected attributes for creating access path, which is nothing but an index. The selected attributes by the used by the queries and the transactions with the time constraints, they get a higher priority for becoming the primary access structure. So now here we have another attribute, time constraints getting associated with the attributes, or that becomes the candidate for creating the access structure or the access path, also called as index. So it means like the attribute that you're going to select to make an index over it, okay, is done by associating the timing constraint, also the time constraint, like how fast it will run. For example, it is better for me to create an index based on the academic ID, okay, rather than having an attribute which is not suitable for becoming the index. So we have just a time constraint getting associated in order to make the performance better. Now, the fourth factor is to analyze the frequencies of update operation. How often you use update operations in the database is also very important. A minimum number of index should be specified for a file that is updated frequently. Okay, so it is said that, you know, if you are going to access table A maybe 50 times a day, then have less number of indexes in it, so that you can access it faster. It is, you know, something like, you know, for example, if you are it's like creating a shortcut for a WhatsApp chat. For example, you are, you know, in the WhatsApp we have something called as pin the contact, right? So if I pin the contact, it will become you know, first in my WhatsApp list, to whom I can, you know, read the messages or send the messages to. So if I am, you know, now you can consider this pin as an index table. Okay, now it is saying that if you are accessing a table for changing the values or updating the values, remove the index, okay, and keep it like a shortcut. For example, I can have the icon of that particular contact kept on my home screen, so I don't have to, you know, enter and access the WhatsApp and then see the list one after the other. Rather, I can place the contact that I am, you know, updating many times a day as a shortcut, and then it provides me the faster access. So it just says that if you have a table, okay, which is getting updated many times a day, then remove the number of indexes on it, okay, because an index is also going to take extra extra performance related things and extra calculations. So we don't want the indexes to be there on the table which is getting updated oftenly in a day. Now, the last one is analyzing the uniqueness constraint on the attribute. Indexes should be specified on all candidate key attributes. So we can define the index or the access path on all the unique attributes or the fields of the table. or it can be created on set of attributes. For example, you have a candidate key or a primary key, which is collection of two keys, okay, first name and the last name. Usually when we create the users tables for login, we create the user ID and the password together as the primary key. So it can be a single key, or it can be a candidate, it can be a set of attributes key. For either primary key or constraint key to be unique. So that is the reason why in the user tables, that is used to create for login information, we have user ID and we have password, and combination of these two to become the primary key. So that, if I have a same password as of my friend, but our user IDs are different, right? So this is about analyzing the uniqueness of constraints on the attribute. With this, we have discussed the 5 factors related to the database design in the relational databases. Now let us see what are the design decisions. How do you design? How do you decide the design of the database? That depends primarily on 2 factors. One is called as designing about indexes, or the decisions related for creating and deleting indexes, or denormalizing as denormalizing the tables for speeding up queries. Now we talk about these two things in the design decisions. Now let us look into the first one. When you are designing an index, you have to make sure that the following questions are addressed. The first one is whether to index an attribute or not. For example, you don't want to index the employee name attribute in the employees table. So you decide whether to index attribute or not. Okay. The second one is what attribute do you want to make an index on. You can decide that it can be a single attribute that can be made to act as an index, or there can be couple of attributes to make an index on. The third one is whether you are going for a clustered index. You remember there are different types of index: primary index, secondary index, and the clustered index. So whether you are setting up a cluster index, which is indexing the groups, the groups classified as clusters together. So whether you are setting up a clustered index or not, whether to use a hash index over a tree index. So you may go for B trees or B plus trees, or you can go for hash index. So you decide what type of index do you want, whether it be a dynamic hashing used for a file. So these are the questions that you have to address while you are trying to make decisions for the type of index that you're using for your database. Because they each of them, for example, deciding to use B plus trees, it will have its own benefits and drawbacks. Deciding to use a heap tree index, it has its own design, it has its own benefits. For example, the time that it will use to access all these things depends on the type of index you decide to make for the table. Okay. Now, the next thing is denormalizing. Normalizing as design. Okay. Now, let us talk about normalization. You remember we normalize the data in order to have the benefits of first normal form, second normal form, third and fourth, and the fifth normal form. But at times, the database administrator can decide to denormalize the database in order to speed up the queries, to speed up the running of queries faster. So the goal of normalization is to separate the logically related attributes into table to minimize redundancy and thereby avoid update anomalies that cause an extra processing overhead to maintain the consistency of the database. It means that when you divide or when you normalize the school database, you will want to store the information about the students in a separate table, information about courses in a separate table, information about teachers in a separate table. And then why do you do that? Because we want to have a logically related attributes in one place. Okay, and we want to do this to minimize the redundancy that we discussed already in the normalization in the DBMS concept. Okay, we don't want to have a repeated attributes in more than one table. We don't want to have it like that, because it will create a problem of updating. If I have a redundant attribute stored in 3 tables, when I make a change in the value of it, I have to make sure that I make changes in all 3 of them, and it is going to take a lot of time from me for doing that. Okay, so we want to reduce the redundancy and the update anomalies, but doing that will make the database, no doubt it will make the database consistent, but it will have its own processing overhead. Okay, so removing the redundancy, taking care of update anomalies, okay, they itself create some overhead. So in order to save our time from that overhead, what do is we denormalize, we get back the data, and we want most of the frequently asked or queried data in one table. The goal of denormalization is to improve the performance of frequently occurring queries and transactions. Typically, the designer will add attributes to the table that are needed for answering queries or producing reports, so that a join with other table is avoided. So it is like, for what is the most frequently used data in the school database. For example, the attendance is being used, every day. So what is done? A separate table for attendance is made, where you have the information about the course, the teacher, and the student in one place, so that when I am trying to run a query against a student being present for a specific course for a specific teacher, then I don't have to write a query which is joining student table, teacher table, and attendance table, and giving me the attendance. Rather, we create one table, bring these attributes, student name, teacher name, attendance, and the course name and the timing in one table itself, so that the one table is updated at a time, and all the other tables is no more needed to join. Okay, so these and use the trade-off between updates and the query performance. So the more often you update, the query performance has to be taken care. So you can do these additional things of denormalizing the database to improve the performance. So with this, we complete the first part of the chapter 20.